couple of years ago, I have become a senior citizen and have developed the habit of rambling. And please pardon me for indulging in it for a few minutes. The reason I'm going to do it is because, to some extent, the way I tend to approach teaching was strongly influenced by what happened to me as a +2 student and also as an undergraduate. So when I was a +2 student, like most others, I underwent coaching for JEE, except that in those days, these established coaching classes were not there. So I went to one professor for physics, another professor for chemistry, and a third professor for maths. And the chemistry and maths professors, they covered the syllabus. They taught techniques of solving problems. But the physics professor presented the subject as some kind of a unified structure, developing it in a very systematic way. Which is why, even though I did a BTech, later I switched to physics. And also during my BTech, we learned a lot of theory. But then when we went to the lab and tried to design circuits, rather not really design, but make circuits and see how they behave, they hardly ever behaved the way the theory told us that they should behave. So in that sense, at least in my mind, there was some kind of disconnect between theory and practice, which is why I went to theoretical physics, so that we can forget about practice altogether. And that is how I did my PhD in particle physics. And actually, my thesis advisor, he is famous for interacting with experimentalists, but as far as my PhD is concerned, he told me to do some calculations, and I learned those calculational techniques, did those calculations. But then I came and joined as a postdoc in TIFR, where I was expected to talk to the experimentalists, give them feedback, and take feedback from them, so that it's an integrated system. And that's when I actually made an effort to overcome this prejudice I developed about there is a disconnect between theory and practice. And I tried to sort of make adjustments and try to see the connections between theory and practice, and why theoretical ideas, where they work in practice, and if they fail, what is the reason for that failure. So these ideas I started slowly developing. But when I joined IIT Bombay, to some extent, my teaching philosophy was similar to what I was as a PhD student. So you describe the theory in as clear mathematical detail as possible and let the students solve the problems. In some sense, an extension of the JEE coaching they had. But slowly over the years, especially when the class sizes started becoming bigger, I was compelled to change this point of view, especially as Salil said, that older way of thinking meant if I continued that older way, I was not making connection to the students, and I had to develop a way to connect to the students. And so that was when I sort of started including some practical aspects of what we are talking about. And to give you two examples, right now I am teaching a first year course where I had to introduce the concept of gradient. And in principle, it's a You can introduce it as a dry mathematical object. But first I tried to introduce why it is called gradient, and let's say if one is trying to build a road on a hill, how this gradient actually is used. Of course, building a road on a hill is not really exciting for the students. So I sort of raised the stakes by saying that essentially the same idea is also developed in a huge way in machine learning. All the machine learning algorithms, they sort of set up a function, calculate a gradient, and use the same ideas that I described for road building in order to sort of arrive at an optimal solution and try to identify things. So that, idea being that, okay, the students should get the idea that, okay, this is not something boring, but on the other hand, a deeper understanding of this concept has actually real world practical applications. And Professor Suneet mentioned this history of subject course. I have taught it the last 2 years. I don't know about the students, but certainly I enjoyed teaching the course, because I have, over the past 30 years, I have spent fair amount of time trying to understand how the famous scientists got the ideas. It's not that they all dreamed their ideas suddenly. There's always a background, and what was the background which pushed them towards that idea? That was what I was interested in. So I tried to tell that to the students as stories. But of course, we are also interested in knowing how much of that they have absorbed. So every week I used to pose a Moodle question which the students have to answer. And in fact, most of the credit was to those Moodle questions. And as Rama Devi said, and as Professor Suneet said, students are free to talk to each other and in fact, I encourage them to have discussions with each other. But the only condition is, if I see 2 identical answers, both students will get 0 credit. And well, at least I like to believe that it has helped the students appreciate the course better. And so, yeah, and one thing I emphasize to the students is they must talk to each other much more, and that way they will learn the subject in a more, they will get a more intuitive grasp of the subject rather than sort of just doing exercises and talking to the teacher. So I always tell, if you have a doubt, talk to your fellow student first, so that even if you don't understand, at least it will sharpen your understanding of what you know and what you don't know. And then you can come and talk to me. So that is something I always tell the students at the beginning of the course. Yeah, these are some general remarks that I wanted to make. And finally, one thing Professor Suneet said regarding economics, if there is a difficult topic which I want the students to really understand, I use an economics example. Especially one thing we always do in physics is when to make an approximation. And I feel that it is if the students will grasp it much better if you do that in the context of money rather than anything else. And another thing, of course, is, for example, one thing which we struggle, and I struggled as a student and I've struggled as a teacher, is try to describe statistical mechanics and the concept of ensembles and distinguishability. There again, I think money, imagine Mint putting out a lot of coins. How do you distinguish the coins? That way, you can give the students a visualizable picture of what we are trying to do when we discuss statistical mechanics. So, there are a lot of abstract concepts that we introduce, but I try my best to give a situation where students can visualize these as these abstract abstract concepts in a more, so that they can get a better understanding of the situation. Yeah, these are some of the points I wanted to share with you.
So we have an economics professor as well. Open for questions for that. Hey, just
You're just mentioning about asking a question where the students answer. If two students get the same answer, give the same answer or come up with the same thing, then you get 0 grades. Which sort of goes contrary to my understanding of what my previous question to Sunit was, because the sort of course content sort of is quite similar.
Yeah.
Okay. So effectively the answers would also tend to be similar.
Right. But this is the example I give. Suppose I ask you to ask the students to write 10 sentences about cow. So each sentence will probably contain 10 words. So there's a pattern of 100 words. But if exact same 100 words in exact sequence appear in two answer books, that's to me, that's an indication that one person blindly copied from the other. Because the Moodle questions I pose, there is some calculation involved, but on the other hand, the student also has to describe in words what is being done. So it's not just writing one equation after another.
This is talking about the history course.
Yeah. This is in the history course.
Yeah.
But on the other hand, for example,
The reason why I brought this up is we have this problem which is easy for us. Because if I say, come up with a story to my students, I can. If two people come up with the same story, then it doesn't work. So everyone will automatically come up with a different story. So that parity between different students' answers is very natural, which I'm struggling to understand whether. But it is good because what happens is the variety of the answers, everybody gets to learn from everyone.
Yeah.
You know, which I see is a difficult thing which you seem to have cracked. Okay, of how to get that difference in the responses to questions, which might be a very nice, interesting.
By the way, 15 years ago, I was teaching the quantum mechanics courses that Ramadevi has been teaching recently. And actually, I used to give, because in quantum mechanics, one has to practice doing long, involved calculations. So I used to give 50% credit for assignments. Yes, the answers required writing equation 1, equation 2, equation 3. But still, if you go through the assignment answer sheets, one can make out when the student is copying and when the student has put some mind. Because there is usually, you need to put in some link sentences between equations, and based on that you can make out whether the student copied or put his or her mind to solving the problem.
I don't have a question of comment. mostly this happened during the COVID time. Like we are asking students to submit assignments and like they have no idea what is happening. I think I was on the stress faculty or something. So what I said is that in the first page of every assignment, every student has to just write a sentence that I have not copied from anyone. Ask them to write it and sign it. I think that makes a difference. I mean, if you have copied it, it's very difficult to say you have not copied. So I think that did help. I mean, instances of copying did come.
Yeah, I have questions like no idea about this quantum course. You use economics in that or some other course?
No, I have not used economics in quantum course, but I used it to motivate statistical mechanics, which is actually a much more difficult subject to teach. Because, I mean, one is imagining Avogadro number, 10 power 23 atoms, and we say that, oh, I can keep track of them. Okay, if you talk about coins, we are not talking about 10 power 23, but let's say 10 power 10, which is, as far as counting is concerned, 10 power 10 is also a very large number, but a student can visualize.
Richest man in the world.
Hmm?
You'll be the richest man in the world.
But certainly a student can visualize how to keep track of coins.
Is it theory or is it application-based courses are generally in science and technology? What the students prefer? Because you guys are all nowadays and all. Generally, what's the trend people are in this? Or is it not the question?
I mean, okay, it's strictly speaking, I mean, Rama Devi and I are not the people to whom you should ask the question, in the sense that, I mean, the theoretical physics is a discipline where you tend to think in a somewhat abstract manner, not worrying too much about application.
In economics, we have a debate on application versus theory.
Yeah.
Is it applies to the real science and technology?
Yeah, certainly.
See, there's a distinction.
I have a question.
Yeah.
So you talked about getting students to write different answers or avoiding identical answers, which is indeed very nice. My only question is, what is the size of the class then?
That I agree. And in that sense, the EP batch is about 60. And yes, it takes me about 3 hours to grade an assignment, but sometimes I don't have that 3 hours every week. So quite often I'm delayed in grading the assignments, but I was able to do it. But in CSRW with classes of 200, it would be more difficult. But on the other hand, I believe you run them in 2 batches. No? You teach all 200.
We are forced to standardize the tests, and that's our biggest problem, scaling. As you scale, you are forced to standardize your evaluation.
Right, I agree. In fact, I mean, for example, old-fashioned JEE versus current JEE, when it shifted to the current JEE format, there are a few of us, Murugavel of chemistry is one of them, who vehemently argued against it, saying, no, we must have subjective written answers in JEE. Because, I mean, that is where you really do test the understanding of the students. So in some sense, I'm very unhappy with this standardized testing that's happening, and I firmly believe that it diluted the quality of coaching being imparted in the coaching classes, which in turn has diluted the basic understanding, basic analytical skills of the incoming first year batch.
So maybe we can switch to the last
So they take it, and then if we have some time.
By the way, I want to share one very small thing. So as I mentioned, I have been HOD till recently, which meant I skimped on my preparation. So I taught a fairly advanced course to second year MSc students, and one of them wrote in my comment, in the comment section, Professor Umasankar taught very well on the days he prepared.